Sets and Probability Bookwork, page 1. First, I'm just going to go through these notes here. Um, a set is simply a collection of objects. Okay, so a set can be numbers, so like all the even numbers is a set, or the real numbers are a set, or the integers are a set, or it could be things. It could be four-legged animals, or um, seniors at EAC. Okay. Um, if you remember the first couple weeks of math studies junior year, we talked about these special sets, and they're the integers represented with a z. They're the positive integers, which are the numbers greater than 0 that are whole numbers. And there's the natural numbers, which is almost the same thing, except it also includes 0. And Q is a rational number, so rational numbers are fractions, okay, can be represented as fractions. And what is not a rational number? Well, the decimals that go on forever without repeating, like pi and square root of 2. A set of real numbers um, is all the numbers we work with in math studies. Um, and then here's some examples here. So it could be numbers, it could be a description, okay? What's n with a in parentheses? It's the number of elements in the set. So for example, NA here would be equal to 5. Okay, the circle with a line through it is the empty set. It can also be written as an empty brackets, okay? Usually you say that when there's no solution. There's finite sets, there's infinite sets. Finite sets have a certain number of elements, and infinite sets are sets like the set of numbers, any kind of numbers. Usually that's an infinite set, no limit as far as what's in there. Okay, now we're just going to do a few of these examples. uh, let's see, for example, example M. List the elements in M, state the number of elements in M. So this says X such that um, 2 is less or equal to X is less than 5. So, and the X is an integer. So the possibilities are like 2, 3, 4, 5. Now, do we include 5? No, because it says less than 5. So only 2, 3, and 4. And so to put that in a set, we would put it in brackets, and then we put commas in between them. Okay, so that's the set M there. Let's try the set S. The set S is interesting. It's a set of coordinates. So, but what coordinates are there? The coordinates on that satisfy this equation, x plus y equals 5, such that x and y are both positive numbers greater than or equal to 1. So let's see. I'm going to put some coordinate pairs here. If x is 1, for example, which is the smallest it can be, y would have to be 4, right? Because they need to add up to be 5. Okay, so that would be one pair. Of course, 4, 1 would also satisfy the equation. Let me see, what if x was 2? Then what would y be? It would be 3. So 3 comma 2 would also satisfy the equation. And then, let's see, is there anything else? No, I think we've already gotten every single combination because we can't use 0 and 5 because it says that it has to be a number that is a positive integer, so starting with 1 and so on. So there would just be these 4. Okay? Now, if you look at this one, we're not going to do it, but you can see that it's the natural numbers instead of the positive integers. The natural numbers would be numbers starting at 0, so there would be also 0, comma 5, 5, comma 0, right? Let's do this one. V is the set of numbers P. such that p is a prime number and multiples of 4. Well, what are the prime numbers? Well, it's like 1, 2, 3, 5, 7, and so on. Now, which one of these are multiples of 4? Well, you'll see that you'll never get a multiple of 4 because 4, 8, etc. Those all have 2 as a factor, and so since they have 2 as a factor, they're not prime. Prime numbers do not have factors except for themselves and 1. Okay? Um, let's see. Let's move on here to number 2. Here are 3 sets. A is the numbers 1 through 6. B is the even numbers from 2 through 10, and C are odd numbers from 3 to 11. List the elements of the sets given by, so let's see, the numbers in A that are greater than 3. Well, there's 4, 5, and 6, right? Let's go to this one with the coordinates. The coordinate pair xy such that x equals y, and x and y are from the set B. Well, so there's, 2 comma anything here, 2 comma 4, 2 comma 6, 2 comma 8, 2 comma 10, but it has to be x equals y, so the only combination that satisfies that would be 2 comma 2. Now what else could you have? You could have 4 comma 4, you could have 6 comma 6, because these are all numbers from the set B, right? 8 comma 8, and 10 comma 10. Okay? And moving on. How about this one? The numbers x such that x equals 2y plus 1. Y is from the set B. Ooh, what was the set B again? Set B is 2, 4, 6, 8, 10. Okay? So y is from the set 2, 4, 6, 8, 10. And x is basically equal to 2y plus 1. So 2 times 2 plus 1 is 5. 2 times 4 plus 1 is 9. 2 times 6 plus 1 is 13. 2 times 8 plus 1 is 17. And 2 times 10 plus 1 is 21. So the set here would be 5, 9, 13, 17, 21, because these numbers are all derived with the formula 2y plus 1. Okay, set builder notation. Set builder notation, which we've been using a little bit here, is, you put the variable x or y or whatever, and then you put a vertical line, which means such that, and then you put the conditions afterwards. Okay, so for example, x is between 0 and 5, or the sum of x and y is 5, or p is a prime number. So let's try to express some of these in set builder with set builder notation. For example, let's take this one. Okay, so this would be the set of all numbers x such that, and it looks like they're integers, so we'll say, oh, x is integer. And not only are they integers, but they are also between -2 and 2. So we could also say -2 is less than x is less than 2, right? So these are the two conditions for this one. X is between -2 and 2, and x is an integer. Let's try this one. So these are the numbers x such that, and you can see that these are multiples of 3. How do we express that with set builder notation? Well, we'll put that, hey, x is a multiple of 3. We could say, hey, x is 3 times y, and y are the natural numbers. Okay, so the natural numbers are 1, 2, 3, 4. If we multiply the natural numbers by 3, we're always going to get multiples of 3. Okay, all right. If every element in a given set, M is also an element of another set N, then M is a subset of N, and we write that like that. Okay, a proper subset is one that is not identical to the original set. So you see, like, if you see the subset notation like that, that means that the subset could be the same as or, slightly smaller than. Okay, so m is either the same or slightly smaller than n. You can see that this notation kind of looks like less than or equal to. So this bottom line you can think of as equal to. So it's a subset or it's equal to. A proper subset is definitely smaller than the other one. Okay, so it means that everything from n, m is inside n, but there is some element of m that is not in n. Okay? I'm sorry, there's some element of n that is not in m. So m is missing some elements relative to n. So for example, if m has a, b, and c, then n would have a, b, and c, plus it would also have d, right? And it would have to because there's no horizontal line there, which would indicate that they could be equal. Okay. And then the other thing they say here is that the universal set you draw as a rectangle, and next to the rectangle you put a U, which means the universal set. Okay? And then you draw your Venn diagrams inside the universal set, and we worked a little bit with Venn diagrams about a year ago. Hopefully you remember some things. Okay. And so we have some sets represented here, and we can use these sets to determine if these statements are true. For example, let's try this one. S is a subset of T. Okay, so what's S? S is the coordinates where the x and the y coordinates add to 5, and x and y are positive integers. So this could be like 1 comma 4, 4 comma 1, 2 comma 3, 3 comma 2, right? I think we did this one above there. And then t is similar to that. Not only do we have all these repeated, but we're saying they could be any integer. So that means that includes negative integers and zeros. So we can include 0 comma 5, 5 comma 0. We could also include negative ones like negative 1 comma 6, 6 comma negative 1, and this could just get out of hand. We could have infinite of these, right? Because when you include negative numbers, you could just put any number in there. You could put like negative 100, and then you would put 105, right? So this set is one of those infinite sets that could go on forever. So is S a subset of T? Yes, it is, right? Because every element here is an element of T. Okay? Let's take some of these special cases. For example, it says the empty set is a subset of W. Yes, the empty set is a subset of any set. Okay? It's not a proper subset of any set, but if you have the horizontal line here, yes, the empty set is a subset of W. Yes, that's true. Okay? And now what about W is a subset of itself? Yes, it is, because W has the same elements that W has. So if it has every single element, then yeah, as long as the horizontal line is there, we can consider it a subset. So that is also true. Okay, and that's what I'm going to be doing today for the first 2 pages.